It's not possible. Listen, if there's one thing the history of evolution has taught us, it's that life will not be contained. Life breaks free, it expands to new territories, and it crashes through barriers painfully, maybe even dangerously, but
Life is resilient, but how much so? At what point can we conclude that a particular extreme environment is truly inhospitable, barren, and lifeless? What are the limits of life? Who better to answer these questions than the champion who has been around over 500 million years and has survived through all 5 mass extinctions without pretty much breaking a sweat? The tardigrades. Tardigrades are 8-legged microscopic creatures found pretty much everywhere on our planet. They belong to the class called Tactopoda, although there are no close relationship with any other creature on the planet. Therefore, their true ancestral history is still heavily debated. Due to their appearance and habitat, they are also known as water bears or moss piglets. They are polyextremophiles, meaning they show incredible adaptation to different forms of environmental stress and come out unscathed. But just how much? Let's categorize their performance in 6 extreme stress tests. The tardigrades could withstand temperatures as high as 150 degrees Celsius, that is 1.5 times the temperature of boiling water. However, on the colder side of things, their survival ability is unfathomable. They are known to have survived temperatures as low as 1 Kelvin, that is minus 272 degrees Celsius. The tardigrade's survival temperature range comes out to be a whopping 422 degrees Celsius. This is unlike any creature on the planet. Just like Superman, the tardigrades can pretty much take on a speeding bullet. Not joking, we literally tried. They can even survive projectile impacts up to 3000 km per hour, almost 900 feet per second. They tolerated shock pressures 1.14 gigapascals in lab. Much like temperature, their survival pressure range is truly astronomical. They are the only known creatures to have survived on harsh outer space for 10 days, a feat once assumed impossible. Once brought back to Earth and rehydrated, 68% of them actually popped up as if nothing happened. On the higher side, some species can also withstand pressures of 6,000 atmospheres, which is nearly 6 times the pressure of water in the deepest part of the ocean, the Mariana Trench. Tardigrades can survive at altitudes of more than 19,600 feet and depths of more than 15,000 feet below the surface. Tardigrades can survive radiations as much as 5,000 Gray. To put this into perspective, the average human can take only 4 to 6 Gray of radiation, so the tardigrade is almost 1,000 times more radiation proof than us. They achieved this remarkable feat due to a damage suppressor protein which essentially shields and even repairs their DNA from radiation exposure. These tough creatures can go on for almost 10 years without even a single drop of water or any food, and once they find even a few drops, they are good to go again. Think intermittent fasting on steroids. Well, you get it by now. They are resistant to all sorts of chemical toxins that would pretty much kill any other life form. But how do they do all this? It's through a process called cryptobiosis. Cryptobiosis is a process in which a creature essentially suppresses all metabolism and goes inactive during adverse environmental conditions. In this state, the organism can live for a longer period until the conditions are favorable again. Tardigrades are truly the kings of cryptobiosis in the natural world. When faced with adverse conditions, they roll up into a ton state. In this state, their metabolism rate drops to a mere 0.01% of their natural state, and almost 97% of the water in their cells are ejected out. A sugary gel called trehalose protects their organs from failure, and with that, they are ready to take on anything. The implications of tardigrades' robustness is paramount in terms of our understanding of life's resilience. Modern science is obsessed with finding hospitable conditions beyond our planet. These tiny organisms are absolutely redefining our perceptions about life and where we can find it. The fact that they survived space opens up possibilities beyond our wildest imaginations. And this is just us on a tiny planet called Earth making assumptions about the limits of life. How arrogant! If one tiny organism in our otherwise rich, nutrient-full planet can survive this, who knows what kind of resilient creatures might be out there in the vast cosmic ocean.